Hello, my name is Juan Carlos Correa, and today I am going to talk about applied complexity for social sciences. The motivation for the following talk is the following question. Is psychology a scientific discipline if we remove psychometric based research and human based experiments? Well, this talk is all about to illustrate some of the benefits of adopting the concept and methods of complex system science or applied complexity for understanding social and economic phenomena. Applied complexity is an interdisciplinary field focusing on understanding how large amounts of interacting components at small scales might spontaneously self-organize, adapt, and change at larger scales without a centralized controller. The properties of the whole system cannot be predicted by knowing all of its interacting components. You can find more information about these notions in this link. Complex systems are everywhere, from moving vehicles creating urban traffic to cellular synapses in the nervous systems and buyers and sellers interacting in markets or speakers and listeners using communication channels. All of these phenomena can be studied from the perspective of applied complexity with few theoretical principles. So the first principle of all these notions is interaction. The term interaction refers to the possible ways in which individual components of a system relate to each other. In the nervous system, for example, each cell is the individual unit of the system, and the interaction between them can be described in terms of chemical or electrical synapses. However, they are not sufficient to explain how consciousness emerge. In the written language, each word or letter is the individual component of the system. However, they are not sufficient to understand how jokes or sarcasms emerge. Emergence is the other principle in applied complexity. In complex systems, we cannot aggregate or sum the interaction of components because the whole is more than the sum of its parts. Dynamics is the third principle. And dynamics refer to the property of a system of changing its states as time goes by, exhibiting unpredictable behaviors in the long run. These changes can be linear if it is proportional to changes in time and its variables or its environment, or nonlinear otherwise. In some cases, tiny changes in the environment might change the behavior of the system entirely. For example, in the case of bifurcations or phase transitions, chaotic systems are extremely sensitive to tiny changes in the environment. So complex systems might also depend on its trajectory. And the future state of the system not only depends on its current state, but on its past states. Self-organization is another principle and is an increasing order or reduction of entropy of the system. Self-organization leads to spontaneous and non-trivial patterns of behavior that do not follow any specific goal or plan. For example, the flocking behavior of birds, a zygote cell splitting itself into creating an organism. Adaptation is another principle. It refers to the property of the system able to change its behavior according to the conditions of its environment without losing the ability to recover its previous functionality and or with the ability to gain new functionalities. For example, in the case of the immunological system, learning how to respond to new pathogenic agents. And interdisciplinarity is perhaps the most significant property of this applied complexity perspective in terms of that the search of common properties between different types of systems is not entirely in vain. These common characteristics might be described by using the same scientific models that rely on well-known principles of mathematics, physics, biology, economics, psychology, and computer science. So we can use and exploit the benefits of agent-based models, well known in computer sciences, neuroscience, game theory, which is well known in economics, systems dynamics, which is well known in engineering, Monte Carlo simulations, which is well known in statistics, artificial intelligence, information theory, or evolutionary biology. So, from this perspective, we have a set of different frameworks like game theory, collective behavior, networks, evolution, and adaptation, and so on and so forth, that allowed us to understand complex systems in different scales and in different time scales as well. So, based on the previous ideas, we have accumulated a set of inspired publications. In first case, as a result of my doctoral dissertation, we have published this article that deals with the behavioral interaction of road users in traffic by showing and deploying the development of an agent-based simulation model, which make use of the agent-based modeling approach. Also, we have published this paper which exploit the benefit of using natural language processing techniques to understand ideological consumerisms in Colombian elections and showing the links between political ideology, Twitter activity, and electoral results. As well, we have published the relationship between economic complexity and scientific productivity of nations as a way to understand or as an approach to understand economic development. As well, we also have published this paper in PLOS ONE about the predictive role of education as a predictor of economic growth by using an alternative measure through structural equation modeling. And more recently, we have published this paper about the evaluation of collaborative consumption of food delivery services through web mining techniques. And this paper, we have explored the benefits of using web scraping techniques and data mining techniques to understand whether or not the traffic, urban traffic, is captured by tools like Google Maps or Waze are actually a good predictor of early deliveries of food in the city of Bogota, the capital city of Colombia. And finally, more recently as well, we have published this paper about what makes a tweet be retweeted by using a Bayesian triggering analysis perspective and allowing us to understand in the context of Twitter uh, what uh, what is the content what is the content of tweets that makes them more prone to be retweeted. So what are the lessons if we take all these publications combined? Well, in first place, it is possible and desirable to study human behavior from an interdisciplinary perspective. Also, it is more relevant for the development of both theories and methods in social and economic sciences. Adopting the perspective of complex systems might be strategic for research, publishing, and teaching, and it promotes scientific collaboration with colleagues of other disciplines and the use of common language for describing and explaining the phenomena of interest. Um, well, this is all the ideas that I want to share with you today. Please leave your comments below. Uh, See you soon.